Now there are two ways of going about creating clothes. If you have 3D Exchange pipeline, you can actually export out an FBX file that will include your custom character and that character's skeleton. If you don't have 3D Exchange pipeline, or if you don't have 3D Exchange at all, that's okay, because if you go to Reallusion's website, this website right here, and this specific URL over here, you can actually scroll down, and if you'll see down here, they have templates, and you can build your clothes around these, and we have both FBX and quad OBJs as shown here, and you can build your clothes around the OBJ and bind them to the FBX file, and this is the method that we're going to be using for this tutorial. I'm going to be using ZBrush to create our character's clothes, so let's import in one of our templates. So I'm going to go into that template folder that I downloaded from Reallusion's website. In here in the body templates, I'm going to go to OBJ with quad mesh, Y up. Since we're making clothes for a female character, I'm going to select female and female OBJ. I'm going to be demonstrating this process with her shirt. So the first thing I do is start painting a mask that forms the rough shape of the shirt. Which I then extract. With the new subtool extracted, I can start cleaning it up using the Move brush and the Clay brush. I also use a bit of the H-Polish brush. Now here's another useful tool for cleaning your extracted meshes. I switched over to the Clip Curve brush to start cleaning out the edges of the shirt. Right, let's skip ahead a bit. And at this stage I turned on the Dynamesh for the shirt. What I'm doing here is making polygroups for the sleeves. I'm going to do a group split to separate the sleeves from the torso portion of the shirt. Then I hit close holes on both meshes under Modify Topology. I use Dynamesh again so that I have some cleaner sculpting topology. Once I have the shapes that I want, I run ZRemesh on my subtools so that I have a cleaner sculpting mesh for multi-resolution sculpting. We're going to be needing those multiple subdivision levels for this next step. Now let's sculpt some folds. I'm going to be demonstrating that on this sleeve here. Now for the folds, I tend to use the standard brush for the large folds, and the clay buildup brush for the smaller folds. I can clean up my strokes using the H-Polish and the smooth brushes. Now let's move further along. At this point I want to add in some seams. I just used the damn standard brush to make the crease and then refined it with a pinch brush. If you want to add in a bit of bulging to the seam, you could turn up the brush modifier for the pinch brush, or you could go over the seam using a standard brush after pinching. Right, now I'm creating a mask to extract some geometry for the front of her shirt. After extracting, I can delete the portions that I don't want and also clean it up using the H polish brush. And once that's done, I run ZRemesher on it so we can have cleaner topology. So here I have a button mesh that I made, and I'm going to use this as an insert mesh brush. Remember that to use an insert mesh brush, you can't have any subdivisions on your subtool. Now I'm separating the buttons into their own polygroups so that I can use the group split on them. And with the subtools separated, I can now add some subdivision levels for the front bit. And that about does it for the shirt. Here we have the finished high-resolution sculpt of the clothes. What we want to do now is to decimate this mesh so that we can bring it into Blender and retopologize it there. So I'm going to go into Z plugin, and here we have our decimation master. I'm going to select our this vest portion of the shirt, and I'm going to set this decimation to, so how many polygons is this? This is at 3 million polygons, so I think this we can go down to 10% in our decimation, and I'm going to hit preprocess current. And once those calculations are done, we can just hit decimate current to decimate our mesh. And now I'm going to do this for every other subtool, but for now I'm just going to do this for the shirt geometry. So we have our sleeves and our buttons, our collar, and this front bit over here. And once the decimation is done, we can go over here to our decimation master and hit export all subtools. And we can save out all the visible subtools. So I'm going to create a new folder. Let's call that decimated. And I'm going to save this out as shirt high.obj. Back in Blender, let's now retopologize that high resolution mesh that we exported out. So I'm going to import obj, decimated, and here we have our high polygon object. So I'm going to just combine these all into a single object. I'm going to rename this, call this shirt high, and now we can start retopologizing. To retopologize in Blender, we first create a new mesh. I'm just going to create a plane over here. Don't even have to move this up. I'm just going to go into edit mode by hitting tab, and I'm just going to delete all of these vertices. Now, it's still there, the vertices are gone, and I'm going to turn on a few things so that it sticks to this high resolution mesh. I'm going to turn on snapping down here. I'm going to change this from increments to face, and I'm going to turn on project individual elements onto the surface of the new mesh. And to start retopologizing, all I have to do is hold down Control and right click. There we go. And that's one vertex. I'm just going to keep hitting Control right click. And as you can see, that's sticking to the mesh. And I can just use my basic modeling tools to start modeling this out. And this should conform to the mesh using our snapping. Now, if you're having a hard time seeing what you're doing, you can turn on over here in the display, and where's that display, or shading, there we go, and turn on hidden wire. And over here in our object properties, I think, yeah, I'm going to turn on X-ray. There we go. Now we can see what we're doing. My retopology workflow is very basic. It's pretty much just edge extrusion modeling, just with the low-res mesh sticking to the high-res one. So at this point I have symmetry enabled, and you can do that by adding in a mirror modifier. But as you can see, there are some asymmetrical details, especially as you approach the color. When it comes time to retopologize that part, I'll just have to apply the mirror modifier and continue modeling without symmetry. Let's skip ahead to a more complicated part, which is the sleeves. A lot of the detail is going to be baked into the normal map, but there are a number of folds that are large enough that they need to be modeled in. So start off with cylindrical topology and add in the main edge loops for the joints, like the shoulders and the elbows. You're also going to need a few loops to handle the twisting deformations. Now I'm starting to work on the topology of the folds. As you can see, I'm moving the existing vertices into place instead of cutting through with a knife tool. This is so that I can keep the same general topology for the twist loops. Remember that when modeling like this, you can end up with a lot of n-sided polygons. Make sure to close those up into quads or triangles. When placing UV seams, you want to put them where the seams actually are on the clothes. So I aligned the UV seams to the sculpted seams of the high-res mesh. Then I select all the polygons and hit Unwrap. At this point I add in a color grid texture to test the texture stretching of the object. What I'm doing here is I'm straightening the UV edges along the seams so that any texture pattern I put will follow along with the seams of the shirt. After straightening those edges, you can pin the UVs and run Unwrap again. The UVs you pinned will stay put, but the rest of the shell will be unwrapped in a way that adapts to the position of the pinned UVs. Once I'm done unwrapping, I use average island scales to make sure that the shells are scaled according to the actual sizes of the equivalent 3D mesh. Then here I just manually lay out the UVs. And here's what the UVs look like once I'm done. So Hair and Character Creator is made up of two main parts. First we have the scalp geometry, which is pretty much just a duplicate of the faces on the character's head. And we have the main part of the hair, which are just strips of polygonal planes that are arranged to look like hair. So to differentiate between those two parts, we're going to assign different materials for the scalp geometry and for the hair strips. As you can see right here in our materials panel, we have some we have a material for the hair strips and a material for the scalp. Now let's take a closer look at the UVs of the hair. So going into edit mode, you can see, let's take a look first at the UVs of the scalp geometry. And it's a very simple pelted UV layout like that, so nothing special. When it comes to the hair strips, this is what it looks like. Now obviously we don't have this few hair strips. What I have here is that a number of the hair strips are overlapping. So for example, these 3 over here, they represent the strips of hair at the front, and these 5 back here, those are the strips of hair at the back. So switching over to Photoshop, I can show you the textures of this. Alright, so here's the diffuse texture. I can turn on the UV layout of that. It's a little bit hard to see, but there it is. And I painted these textures using a very basic hair strand brush. And it looks something like this. This is one of a number of variations I have of the hairbrush. So again, very simple. So aside from the diffuse, we also have here, we have our alpha textures, which is the which define the transparency of the hair. And this one I used as a basis for both the specular map and the bump map.